Alrighty, looks like we're recording. So, hi, I'm Yasmin. Welcome to my little mini tutorial. So I'm going to be giving it on simplifying algebraic expressions and particularly collecting like terms. So the first thing that I would typically do in one of my tutor sessions is review the previous week's homework. However, that doesn't really apply here. So I think I'm going to jump straight in. So I also like to give a brief explanation of what the topic is before I start giving examples. So what do I mean when I say collecting like terms? Well, we can simplify our expressions by collecting similar terms, like terms, adding them together or subtracting them, and it just simplifies everything and makes it a lot more clear and concise. So what do I mean when I say like terms? Like terms are terms that are of the exact same form, so they consist of the same letter and of the same power. So the power thing is something we'll get into a little bit later, but first we'll just look at the same letter concept. So in this little example here, we have A plus A plus A. So we have three lots of A. Because A is used throughout, that is our like term, so it means that we can add this together. So we have three lots of A, so we can add that, and it gives us 3A. Another way to think about it is that there is 1 in front of each A, so we can do 1 plus 1 plus 1 times A, which is the same as 3 times A, which is, again, 3A. So that's two different ways to almost think about it. So the next example, we have 3p plus 5p. So p is the same, it's to the same power, they're both to the power of 1, and it's the same letter, which means that we can add these two terms together. So we have 3 plus 5 times p, which is 8 times p, which is 8p. So in between each example, I would check with the student to make sure that they're comfortable with everything I've done, that they're following, and to make sure they don't have any questions. I want them to ask questions all throughout whenever they want, because I don't want them to feel like it's a strict lesson. I want them to feel free to jump in whenever, and I want it to be very interactive, and that's the whole point of this. So yeah. So the next example, we have 10t minus 8t. Again, we have our like terms here, so that means that we can subtract. So we have 10 minus 8 times t, so that leaves us with 2 times t, so we have 2 lots of t. So next example, it's a little tricky because we have y plus 6. These are clearly not like terms, so what we would do here is either rearrange, so we can have 6 plus y, but apart from that, we can't really do anything. That's the only thing we can do. So in like some scenarios, it would help to rearrange like this. Not always, so it just depends, but other than that, it does not simplify. So next example, 10 minus b. Again, not like terms. If it was 10b minus b, then yes, we could simplify this. So we have 10 minus 1b, so we would have 9b. But that is not the case here, so again, does not simplify. So next one, we have 5p plus 2q. These, you can clearly see, are different terms, so we cannot simplify this. So you have to be very careful when it comes to your letters. You have to underline everything. It makes it so much more clear to just annotate as much as you possibly can, write as much as you can. It really helps your train of thought and it will prevent mistakes. So this is a trickier one. We have capital B plus small b. So this is tricky because in English, these would be considered the same letter. B is B, right? But in algebra, it makes a big difference whether our B is capital or if it's not capital, not just B, any letter. Our capital B can represent something completely different to our small b. So these are not like terms. This is a very common mistake to make, to just assume that this is the same thing and add them together as you usually would. You have to be very careful to not fall for that little trick. So next example, we have 7 capital T, take away 3 small t. Again, it's the same thing as before, so we cannot simplify this. Next example, we have 9w minus w. Here, they're both small w's, so we can simplify this. However, one thing to note, a very common mistake that people make here is see the w minus w and assume those take away and it leaves you with 0, so you have 9 left over. But that is not the case. So here, what we effectively have is 9w minus 1w. You must never forget that there is a 1 there. So now we do what we did from before. So 9 minus 1 times w. So that leaves us with 8 times w, which is 8 lots of w. So there you go. Again, at this point, I would check with them to make sure they're comfortable with all the examples, and if they're feeling confident, then they can try a couple of these examples here. And if not, we can go through any of the questions that they're not comfortable with. So, collecting like terms, a little more complicated now. So the first thing I would recommend is to make sure that you have 2 different coloured either pens or highlighters, because it becomes very useful when it comes to these type of examples. So here, let's just read through it first. So we have 5x plus 9 plus 2x plus 1. Well, we can see here that we have some x terms and we have some regular number terms. So let's just highlight them so that we can see them very clearly. So we have our 5x and we have our positive 2x. A golden rule here is to always underline the sign before the term as well. Here, we don't have a sign before it, but because we don't have a sign before it, then it's safe to assume that it is a positive term. So there is a plus here, but it's just not written. So this is positive 5x. And now let's switch colours. So we have our number terms. We have positive 9 and positive 1. So let's rewrite this so that it's a bit more clear and we have our like terms all together. So we have 5x plus 2x plus 9 plus 1. So we can add this together to give us 7x, and we can add this together to give us 10. And that's our simplified form. We can't simplify it any more than that because we have different terms here. We have x and a number, so that's as far as we go. So the next example, we have 4t plus 3r plus 3t plus 2r. So let's underline our t's. 40, positive 40, plus positive 3t. Now we'll switch colours. Positive 3r plus positive 2r. So let's rewrite. We have 4t plus 3t plus 3r plus 2r. So 4t plus 3t gives us 7t. 3r plus 2r gives us 5r. And that's our simplified form. So next example, we have 12v, positive 12v, and positive 3v, and we have positive 10w and negative 9w. So here it gets a little bit more complicated. So 12v plus 3v plus 10w minus 9w. So 12v plus 3v leaves us with 15v, and 10w minus 9w leaves us with 1 positive w, or you can write it as just w. It's just a lot easier to just not write that 1 there. So next example, we have positive 3a, negative 2a, and we have negative 6b and positive 12b. Now, what did I do? Okay, I think we're good. So we have 3a minus 2a, and we have negative 6b and a positive 12b. So let's look at this little segment here. Oh, I should have included the negative. So negative 6b plus 12b. We can rewrite that to make it a lot more clear what's happening. So we can switch around our terms. So we have a positive 12b minus 6b. Because this is a negative term, we can just rearrange it to leave us with 12b minus 6b. And that's a lot easier to see what's going on. Like this compared to this, it's just a lot nicer to write it this way. So we'll rewrite it again. 3a minus 2a plus 12a minus 6. Sorry, b minus 6b. So that leaves us with 1 positive a plus positive 6b, or just a plus 6b. All those look very similar. Alright, and that's our final form. So next question, we have positive 5 and negative 7, and we have positive 2m and negative 6m. So let's rewrite as always, plus 2m minus 6m. Our like terms here leave us with minus 2. So here we're incorporating our negative numbers, so you have to be very careful with those. And here, positive 2m take away 6m, leave us with negative 4m. So what you must never do in this scenario is what I've done here, is write it as plus minus. That is overly complicated, and it's the same as just a minus sign, so it's just a lot nicer to write it like this. You can just get rid of that plus sign altogether because plus minus is the same as minus. So this is our final form. So here we have quite an interesting one. We have 2x, we have positive 3x squared, and we have, let's switch our colours here, we have positive 5xy. So it's very tempting here to try and combine our 2x and our 3x squared. However, this is where our issue of powers comes to play. So here we have x to the power of 1, and we have x to the power of 2 here. So because these aren't the same power, we cannot combine them. So these are not like terms. And xy we cannot combine because it's just not the same letter. We can clearly see that it's x times y, and this is just x. So altogether we don't have any like terms in this equation. So it does not simplify. And there you have it. So again, I will check with the student to make sure that they are comfortable with everything that I have done. And then if they are, I would set them some more questions to do, either in the session if there's time or for homework. Either one is fine. So yeah, thank you for listening. I'll hear back from you soon, hopefully. Thank you.